Hello, Math 8 students. This is Open Up Resources, Unit 1, Lesson 14. Yes, you heard that right. Although we finished Lesson 15 previously, we are going back now to work on Lesson 14. Lesson 14 is called Alternate Interior Angles. However, I call it Cut by a Transversal because we're going to be exploring more than just alternate interior angles. To get us started, we are going to review something that we first saw back in Lesson 9. And we also are familiar with it from our lesson 15, which is why I wanted to do lesson 15 first. It says find the measure of angle JGH. All that's given to us is this angle measure here, JGF is 30 degrees. So how am I going to find the measure of angle JGH? What we should be looking at is the relationship that we see here. From lesson 15, we remember that this is called a straight angle, and a straight angle measures 180 degrees. And since a straight angle measures 180 degrees, we can see that 30 degrees is taken up here by this angle, so the remainder would be taken up by this angle. And so it's just a simple calculation. 180 degrees minus the 30 degrees that has been given to us is equal to 150 degrees. So now I know the measure of angle JGH is 150 degrees. When we continue on, it says find and label a second 30-degree angle in the diagram. And again, this is where lesson 9 summary is really going to be helpful. A second 30-degree angle can be found using the property known as vertical angles. Although we can also use some deductive reasoning, understanding that there's only one other acute angle, so this is probably the 30 degrees, we can prove that these are the same because they are vertical angles. So 30 degrees, and we're going to write this down. We know this because vertical angles are congruent. When we continue on, it says find and label an angle congruent to angle JGH. So again, JGH is 150 degrees. And while I can continue to use the straight angle property, understanding that this 30 degrees will add up to 180 degrees when added to this angle, even easier than that is continuing to use that property known as vertical angles. So, since these are also vertical angles, that tells me that this is also going to be 150 degrees because vertical angles are congruent. In order to be successful, we do need to go back and review the lesson 9 summary. I do have the lesson 9 summary here on the screen. If you have the ability, I would encourage you to pause the video and return to lesson 9 summary, which you will find in Canvas. If you're printing your own materials, you can also find your own paper copy of lesson 9 summary and go over it there. Pause the video as you read through the lesson 9 summary. Here are some things that I hope you read about and reviewed from lesson 9. A rigid transformation of a line is a line. What that means is if I take this line, I can translate it, and guess what? It's still a line. A reflection is a little bit harder to model, but I can take this line and I can flip it up and down, and look at that, it's still a line. We can even take a line, and this one is harder to show. I can rotate it, and guess what? It's still a line. So a rigid transformation of a line is still a line. There are some other important things that were highlighted in the summary, but here's the ones that I want to focus on. A translation parallel to the line will take the line back onto itself. That starts back up here. Sometimes the rigid transformation takes a line to itself, and we can see that here. Again, I've got a line, and if I translate that line in the direction of that vector that I have drawn, it is going to stay that line. Notice, although it might look like it's in a new position, lines are infinite. That means that this arrow shows that it extends infinitely in this direction, and it's not going to stop. So even though it may have moved, know that that does extend to cover the place that it moved away from. So when I translate a line in the same direction as the line is already going, that line stays itself. It stays that same line. Here's something else though, and this is not listed, but it is worth mentioning. If I translate this line in a direction that's not the same as the line, like going this direction, notice what happens. Those lines are parallel. That's going to be important for today's lesson. There are other points that are really important, but we will address them later on in future videos when it's important for those problems. We are going to finish up here. Using these facts from lesson 9, we were able to identify vertical angles. The way we saw this is line A and line C. When I rotate the line containing A 180 degrees, it shows me where A prime is. And when I rotate the line containing C 180 degrees, it shows me where C prime is. And if I rotate them both at the same time, 180 degrees, we can see that the angle that's formed by those two lines stays the same. And that's how we get those vertical angles being congruent, because this 140 degree angle is the same as this 140 degree angle. Again, that is vertical angles are congruent. This is so important, and we are going to write it about 10 more times as we progress through this lesson. Let's see. I think that that's it for the lesson 9 summary for now. I think we're ready to move on to our next exercise. And this is cutting parallel lines with a transversal. We start with the diagram and a description of the diagram. It says lines AC and DF are parallel. So again, let's take a look at the diagram. Here's line AC, here's line DF, and those lines are parallel. And it says they are cut by transversal HJ. Here's HJ, this line. So what does that mean, cut by a transversal? That's a fancy mathematical term that basically means goes through. There is a line, HJ, that goes through both of these lines, AC and DF. It goes through each of them at just one intersection point, and that's what it means for a transversal. Again, it's a big fancy word that basically means goes through. Now that we understand the diagram, we can see that we have one angle measure given to us. This angle measure here is 63 degrees. And it says with your partner, find the 7 unknown angle measures. We are going to do that, but we're going to baby step it. We're going to go nice and slow. Just find these angle measures here. If you're stuck, it might be a good idea to pause and rewind the video so that you can review our first exercise that we started the video with. Look at what we did there and see if you can use that information to help you figure out what these 3 angles are. Pause the video and answer those questions now. What you should have seen is this is a 63 degree angle, and so this is also a 63 degree angle. I know this is also 63 degrees because, and we're writing this down, vertical angles are congruent. It's never enough just to write down the angle measures. We always want to justify how we know what we know. So this is 63 degrees because vertical angles are congruent. We can also use the properties that we used on the previous problem, that we can see a straight angle here. And anytime I see a straight angle, I remember that that means 180 degrees. So I'm going to write that down as well. Straight angle. Remember that that's 180 degrees. So when I have 2 angles that create a straight angle, we would call those supplementary angles. Yes, we are writing this down. This is a new term, something that is going to be used throughout this lesson and the next, so I do want you to be familiar with it. Supplementary. And supplementary, again, just a big fancy math word that means adds to 180. So supplementary angles add to 180 degrees. So with that in mind, knowing that both of these together will add up to 180 degrees, I have 180 degrees minus the 63 that's given to me in the diagram. And when I do that subtraction, I end up with 117 degrees. that means this question mark angle here is 117 degrees. And again, how do I know that? Because it's a straight angle or supplementary angles that add up to 180 degrees. How will I be able to find the measure of this final angle, EBC? Again, there are multiple ways that we can do this. We could take advantage of, again, recognizing that this is a straight angle. We'll add to 180 degrees. But since I've already done the calculation and I know what this angle is, I'm going to take advantage of that special property that tells me that these angles are congruent. And that property is, of course, vertical angles. So yes, I am writing it down once again. Vertical angles are congruent. Now, we've done the hard part. We have answered all of these questions, figuring out all of these angles, all that share vertex B. How am I going to find the measure of these angles? And to answer that question, we're going to use that information from our Lesson 9 summary, remembering that if I translate a line in the same direction as the line, it's going to stay on that line. And if I have a line and I translate in a direction different from that, those lines will be parallel. So with that in mind, I'm going to focus on this line and this transversal. I will also be paying attention to point B. And what I'm going to do is I am going to translate in the same direction as this transversal. So notice as I'm translating, that line is staying the same line, just as it should. And this line, as I'm translating it, is staying parallel to the original. I'm going to continue translating until what was point B lines up with point E. Did you see what happened there? Let's go back and do that again. This angle that measures 63 degrees, when I translate it, is in a new position, but because all I did was just a rigid transformation, I hope it's easy to see that that same angle is still going to be 63 degrees. But now we have a new justification for that. The justification we're going to use is this. It was a rigid transformation. And rigid transformations preserve angle measure. Let's take a second and review another vocabulary word that may have been forgotten. Starting here with this quadrilateral, I might name this quadrilateral W, X, Y, and Z. And now, when I perform a rigid transformation on this quadrilateral, like this translation, we would need to know what to name these points. What should I call this point here? You're probably saying to yourself, we should call it X prime. But why do I call it X prime? Why am I not calling it Y or Z or W? Intuitively, you already know this, and the reason why is because these are corresponding parts. And so we name them similarly. And you also should remember that corresponding parts will have the same measure in those rigid transformations, in those congruent figures. So when I take X and I translate it to X prime, we can talk about X and X prime as corresponding parts. So, although we are able to show that these are congruent through a rigid transformation, I also want us to practice that new vocabulary word, and I'm running out of space. It's getting nice and squishy there. We're going to call these corresponding parts. So we're going to add that and write that in there. Corresponding parts. Specifically, these corresponding angles are congruent. So these corresponding angles are congruent because we performed a rigid transformation to get there. So now I know that this is 63 degrees, and there's so many ways that we can show all of these other angles. If this is 63 degrees, then we know that this is also 63 degrees because vertical angles are congruent. Yes, we're writing it again. We can prove this in a couple of different ways though. Again, if this was 63 degrees, imagine us translating that back up here again, and we can also see that these are also corresponding angles. So you can justify with vertical angles, you can justify with corresponding parts. Continuing on with this, we can see that this was 117 degrees, and I can just translate that angle, and that will be 117 degrees. But we can also use our supplementary angles as well, and see that 63 degrees plus this angle here will add up to 180 degrees. And so just like before, this is 117 degrees. And vertical angles are congruent, so of course this is also 117 degrees. Although there are multiple ways that we can justify this, as long as you have justified it using at least one way, you're good to go. You don't need to write down every possible justification. 117 degrees because vertical angles are congruent. Question 2 says, what do you notice about the angles with vertex B and the angles with vertex E? We've already answered that question. Do you notice that they are the same angles? And again, we need to acknowledge that they are the same angles because we used a rigid transformation to get there. Let's write that down and use that vocabulary term that we just mentioned. The angles with vertex B are the same as the angles with vertex E. Because they're corresponding parts after a rigid transformation. All right, I think you're ready for the next one. Using what we've practiced here, I want you to answer the questions in number 3. Using what we noticed, find the measures of the 4 angles at point B in this new second diagram. And again, it reminds us lines AC and lines DF are parallel. It might be challenging to jump right in to these angles surrounding B. So take a baby step. Now that we know that this is 34 degrees, can you find the remaining angles around here? Then use that information, just like we did in the last problem, and see if you can find the angles surrounding B. Pause the video long enough to answer these questions. What we should see is, since this is a 34-degree angle, and we know that vertical angles are congruent, we also know that that is a 34-degree angle. Let's write it one more time. Vertical angles are congruent. With as many times as we've written this, I hope you understand just how important it is to recognize this property. Vertical angles are congruent. And now we've seen vertical angles are congruent, but there's another property that we can utilize here, and that is we have a straight angle. And again, a straight angle means we have supplementary angles. Let's write that down again. Supplementary angles add to 180 degrees. And that reminds us that when I see this is 34 degrees, knowing that this is all going to have to add up to be 180 degrees, I simply have to calculate 180 degrees minus that 34-degree angle, and that is going to give me the measure of angle DEG. 180 minus 34 degrees is equal to 146 degrees. Now that I know that this is 146 degrees, I can use that vertical angles again. Again, vertical angles are congruent. Now we have found all of the angles surrounding E. How do we use that information to help us find all of the angles around B, which is what the question was actually asking? And again, just like before, use that rigid transformation. Let me quickly demonstrate that one more time for you. when I translate following along on that transversal, eventually I'm going to make it to point E, landing directly on point E. And we can see that because I performed that translation, the transversal landed on the transversal, and this line translated landed on the parallel line. And so we can see then that this angle that was 34 degrees in our original translates down to this angle here for 34 degrees. Again, we would call that corresponding angles are congruent. Yes, I want you to write that down as well. Corresponding angles are congruent. And we can use that same property again and again for each one of these. What is the measure of this angle? Well, this angle translated down, we now have another corresponding part, so we could understand that this is 146 degrees. And we could use that same justification again and again and again, but I want you to have the experience of seeing the other properties again and again as well. 146 degrees, vertical angles, so I know that this is 146 degrees because vertical angles are congruent. Let's check to see if that confirms what we already suspected. This is 146 degrees. If I translate it down, we have the corresponding 146 degree angle. We've proved it twice now. Vertical angles and corresponding angles. And for the final one, we're going to use that supplementary angles property, knowing that this is 146 degrees. I can now see that 180 degree straight angle. Supplementary angles add to 180 degrees. And so, knowing that 180 degrees is the grand total and 146 degrees is taken up with this angle, that tells me that the remaining angle, 180 degrees minus 146 degrees, is 34 degrees, which will give me this angle here. Using that supplementary angles add to 180 degrees. Let's see if that works out. It was 34 degrees down here, and if I translate that, sure enough, it's 334 degrees. I wrote it wrong, but it is 34 degrees. Sometimes I get a little happy with my degree signs and turn them into zeros. 34 degrees. Now, let's compare what we just did in that problem to what it's asking us to do here for number 4. The next diagram resembles the first one, but the lines form slightly different angles. Again, pause the video long enough for you to calculate all of the angles that are missing. This is 108 degrees. Use that information to calculate these missing angles. This is 63 degrees. Use that information to calculate these remaining angles. Continue the video when you have done that. This time I'm not going to make you write down all of our justifications. You've got the practice, but I am still going to show my work. This is 108 degrees, so I know vertical angles are congruent. That will also be 108 degrees. And I can see we have a straight angle here. That means that I'm going to take these two angles and understand that they will add up to 180 degrees. So 180 degrees minus 108 degrees gives me 72 degrees. That means the measure of this angle here is 72 degrees. And vertical angles being congruent tells me that this angle here is also 72 degrees. Now let's switch to the lower angles, the angles surrounding B. And here we can see 63 degrees, so I know vertical angles are congruent. This is also going to be 63 degrees. And understanding that we still have supplementary angles, we have a straight angle here, 63 degrees plus something is going to add up to be that 180 degrees. So 180 degrees minus the 63 degrees is equal to 117 degrees. Knowing that, again, vertical angles are congruent, I can easily find the measure of this other angle, 117 degrees. When we're looking at this diagram, we can now see that we don't have corresponding angles as we had before, and that's what we should be addressing here in number 5. 72 degrees no longer corresponds with the angle below at 63 degrees. 108 degrees no longer corresponds with the angle below that, 117 degrees. And the reason is because in the past we were able to take a line and simply translate it down to its parallel pair. We don't see that this time. In order to get this line to match up, I'd have to translate, but I would also have to rotate. And when we're rotating, we're always saying rotate a certain degree amount. That means that the angle that it was laying is going to be changing. And so we are seeing a difference here because we don't have the parallel lines. Let's make sure we write that down. We no longer have corresponding angles. Because the lines are not parallel. And with that in mind, you're ready to answer this question here, the "Are you ready for more?" Online learners, this is where you're going to end the video so that you can answer this question. I want you to give this a try, and I want you to tell me in Canvas, what is the measure of angle X? You can do this very quickly. Some students it takes about 3 minutes, some students it takes about 30 seconds. Use what we know about parallel lines and about triangles. Here we have L, which is parallel to M. And this pair of parallel lines is intersected by 2 transversals. It's cut by 2 transversals. Here's one, and here's the second. Both of those transversals do intersect right here in the middle. This angle measures 60 degrees. This angle measures 55 degrees, and we're trying to find the measure of angle X. We're going to end the video here. We'll pick up on tomorrow's video, starting right here, but I do want you to give this a try and enter your answer into Canvas. That's it for today. We'll see you next time.